Hi everyone. The topic for today is evaluation of VAE. VAE. Now you know what that means. AE stands for arithmetic expression. V is for val. What was that? To introduce names, introduce identifiers. The syntax was val ID equals E1 semicolon E2 enclosed by curly braces. We are introducing this name whose value is the value of E1. With that information, evaluate E2. While evaluating E2, we may use this name. Before diving into the new material today, let me emphasize that you are supposed to do your exercises. Now that the period of adding and changing your courses is done, right? That was last Friday, and you may not have any other options except just taking this course really well, right? So exercises are gonna help you understand the material that we are gonna cover in this semester better. So we designed various exercises to help you understand the material and to see whether you are following the material well. And we strongly recommend you to start them earlier than later. Not only the exercises, but the more important thing is project number 1. Even only its description is 8 pages. If you have not yet looked at it yet, I strongly recommend you to take a look at that today. Then you're going to see what we are expecting from you just before the midterm exam. Utilize office hours. Actually, that's just Q&A with the Piazza board. Tests for a given template language may not work for your new language, meaning that these exercises, they usually have template languages, and most exercises ask you to change that language or add more language construct to that, and it becomes a new language. And tests for the previous old template language may not work for the new language because you changed the old one to a new one. If you don't know what I'm talking about, you'd better take a look at those exercises. VAE is the language for today. The usual thing for us is to define a new language. The name could be AE, VAE, whatever names. And we define its concrete syntax. We show its abstract syntax. We implement its interpreter interp as its semantics in Scala. And then we show what we meant by those implementation and all that in the operational semantics. That's going to be how we are going to do it today. So let's start with this concrete syntax. The non-terminal is again expert. For any language that we are going to define in this semester, the non-terminal is going to be expert. Again, expert is a set of expressions. This time, there are 5 ways to create an element of the set expert: a number, addition, subtraction, identifier introduction, and use of identifiers. So far, so good. There's nothing new here. We already covered everything I just said last week. And we showed how to implement this concrete syntax in Scala for abstract syntax. So that non-terminal expert is now a trait. There are 5 case classes, right? 5 ways to create an element of this type expert: number, addition, subtraction, identifier introduction, and use of identifier. And when we have such an expression, how are we gonna interpret it? How do we understand what that expression means? Let's look at this. Again, this VAE is the name of a parser, and when we give this string representation of the concrete expression, concrete syntax, then this one is going to translate the string to this type. Okay, so this is a parser that converts something in concrete syntax to an abstract syntax. And this interrupt function takes that abstract syntax, understands, evaluates that expression, and returns its value. So let's see what this expression is. From here to there, it introduces a new name, x. Its value is 1. Okay, so until here, we don't know anything about names, but right after this expression, we know something, right? So in the beginning, we have this empty box, empty blue box. This is gonna be empty blue box. It's gonna keep names and their values while evaluating the expression. So after evaluating this line, we know that x's value is 1. So it's gonna be like that. We are gonna put that information into this blue box. Then we have another name, y is 2. So after evaluating this expression, what do you expect? Yeah, in that blue box, we have a new piece of information. In this blue box, in the beginning, it was empty. After that, we added this information saying x is 1. And now that we evaluated this expression, we added another information saying y is 2. Then, with this information, we can evaluate this complex expression. Oh, it's 100 plus some thingy. And that thing is 99 plus another thingy. And when we go until the deep inside, it says open y plus x close. Then we want to know the value of y. And what can we do? Look up that blue box. Oh, when we get into y and when we want to know the value of y, we are going to look up this blue box and says, oh yeah, y's value is 2. Okay, what about this expression? This one is also from here to there. It introduces a new name. Before evaluating this expression, the blue box is empty. But when we evaluate this expression, we know that x's value is 1. We're going to put that information into the blue box. And then we are going to evaluate this sub-expression saying x's value is 2. Oh, what? Previously, we said x's value is 1. And now we are saying x is 2. Yeah, we changed our mind. What can we do? In the box, x is 1. Do we want to reject this code? Do we want to keep the old information and ignore the new information? Do you remember the semantics of this language that we discussed last Wednesday? Yeah, what we said is that the inner one is going to wins over the outer one. The outer one is gonna be hidden or shadowed. So here, after evaluating this expression, the blue box has only one information still saying x is 2. Then, after evaluating that, we are going to evaluate this expression x, and we are going to look up the blue box. The value of x is going to be 2 instead of 1. So a new mapping replaces any old value. Is it clear? Then let's look at a slightly more complex example. Not really complex, but slightly. Let's see. In the beginning, the blue box is empty. We have this information, x is 1. Okay, x is 1. And what's next? The next expression is addition. Addition of yet another identifier introduction plus number. Identifier. Wait, then what can we do about this blue box? Because on the left-hand side and right-hand side of addition, this plus operator, we need to use this blue box. What can I do? Because we want a fair computation, we are gonna pass the same blue box to both branch. The left-hand side of plus and right-hand side of plus. Okay, that's good. So on the left, x is 1. On the right, x is 1. That's good. Let's look at the first one. On the left. Here, again, we are introducing the same name x with a different value, 2. What can we do? Yeah, after evaluating this one, on the left, we are going to say x is 2. On the right, we are going to still saying that x is 1. Do you see that? Right? Because the addition of the left-hand side of addition and the right-hand side of addition, they have different blue boxes. That's, yeah, obvious, right? So this time, this x has value 2. This x has value 1. So it's going to be 2 plus 1, which is 3. So far, so good? Then, let's implement this semantics. So, we are going to evaluate an expression with environment. The blue box that I have been calling, that's actually called environment. Or in some course or in some programming languages, they call that symbol table or environment. So now, previously, the intro function took an expression and returned an integer value. And now, intro function takes two parameters, an expression to evaluate and an environment. For a given expression and an environment, it's going to evaluate this expression under this environment and returns a value, integer value. So then environment is what? That blue box. Do you remember the blue box? The blue box was like in the beginning empty, and then x is 1, and then y is 2 on top of x is 1 like that, How can you represent that in Scala? Oh, that's cool. By having a map. In Scala, we have a type called map, which maps something, key, we say keys, to the other values. That's what we say, value. So when we say type inf equals map from strings to int, meaning that this environment sigma, this environment sigma is mapping from string to integer, something like that. And we're gonna show you this more formally after the first break. Then, with this Scala implementation, what can we do? In the beginning, the environment is going to be empty. You can create an empty environment by map open close. You can even initialize a map with some initial mappings like A's value is 0 and B's value is 1. Oh, isn't it cool? And for a given environment, we can add new mapping like this. Oh, actually, it's not a new mapping. It's a mapping of an existing key with a new value. Then it's going to be like this. But again, because it's a val, we didn't change y itself. So when we say y plus d's value is 42, now b's value is still 1. See, right? There's no mutation. And d's value is 42. We can even get rid of an existing mapping. If we get rid of a mapping for A, then it's going to be a map with a single mapping. Two important methods are get and get or else. I think you should be familiar with this one because of Jamin's lecture about Scala. But let's review that. From a map, we can ask for the value of a given key. So what's the value that map to the key A? Oh yeah, because A is 0, that's going to be 0. And this get is going to return option type. You should know this as well, right? Option of this time integer. Then A's value is going to be 0. It's going to be some 0. C, it does not exist in the map, so it's going to return none. If you don't want to have this option thingy, you can use get or else, meaning that, hey, what's the value of A? What's the value of C? If they do not have the value, then the default value is going to be 42. That's get or else. Else, give me this 42, the ultimate answer to the universe. Then let's use the actual Scala map instead of blue box in the previous example. Yeah, the same thing. The intro function now takes two arguments. The first expression to evaluate and the environment. In the beginning, the environment is empty, right? The empty blue box. And when we evaluate the first thing, map has new information, right? Which information? Oh, x is 1. There's a typo. I'm going to fix that later, okay? Oh, then what? Here, the map is going to have x is 1. Do you see that? Okay. Then we are going to evaluate this. When we evaluate that one, we are going to say x is 1 and y is 2. And using that, so that was the previously, with that blue box notation, it was y is 2, x is 1. Remember? Just the same thing. That blue box is now Scala map. Finally, when we evaluate y, we are going to look up the environment, get the value 2. Right? Clear, right? So then, how can we implement this, what I just said? We'd like to change the intro function to take two arguments, an expression to evaluate, an environment that has information about names and their values. Previously, when we had only 3 cases, what's called AE, we didn't need this environment. Really? Why not? Because evaluation of a number, yeah, it's just n. Evaluation of addition and subtraction, we only need to recursively evaluate the first sub-expression, the left-hand side sub-expression, get the value. We evaluate the second sub-expression, the right-hand side of sub-expression, the right-hand side sub-expression, get the value, and then either add or subtract those values, and that was it. So we did not need an environment, right? What's an environment again? ENV type. ENV is a map from string to int, right? Meaning that for a given identifier, this environment tells you its value. So we need this environment because now that we have 2 more language constructs called, and the language is now called VAE, we have this new language feature identifier. That's why we need an environment to evaluate an expression of VAE, right? Again, we are learning identifiers. The title of last lectures on last Wednesday was identifiers, right? So this is identifier. If you remember, this ID case class takes only one single field, right? Single parameter of type string. So this is a use site, and this is an introduction site. How are we supposed to evaluate this ID? How are we supposed to evaluate this val, meaning identifier introduction? We are going to learn how to interpret this expression after the first break. And before the first break, we are going to learn how to interpret this name. When you have some code, like what? Say, open, 3 plus x, close. How do you evaluate this one? Evaluate the left-hand side, evaluate the right-hand side, get their values, and then add them. What's the value of 3? Oh yeah, that's 3. What's the value of x? Oh, that's what? That should be in the environment. That's the whole point of having an environment. So, meaning that when we have an identifier saying x in some expression, then we'd like to know its value. We'd like to look up the environment using the name. Look up the environment using the name, meaning that this lookup is a function, right? Just by looking at this, you should be able to know its type. Lookup is a function with 2 arguments. And the first one, what's the type of the first one? What is the x? X is the field of ID. What's the type of the field of ID? String. So, string. And the second argument is EMV. What's the type of EMV? Oh, what is it? You think. What's the type of EMV? Yeah. How did you know that? Because it's written here. This EMV is that EMV. This is a binding occurrence. This is a bound occurrence, right? And when we introduce EMV, we said that its type is ENV. Then it's a function, right? Lookup is a function. What's the result? What's the return type of this lookup function? Now you think again. What is it? Yeah, it's int. How did you know that? Because the value of the whole thing is going to be the value of this int function, whose type is int. Right? It's like quiz or puzzle or detective. I really love detective novels. 추리소설을 무지 좋아했는데요. Because you can collect hints, clues here and there, and then find the criminal. It's not criminal, but you can collect some clues and information from here, there, everywhere, and then you can infer the type of this lookup function. Indeed, the type of this lookup function is what? String and environment to integer. And there's no surprise. Lookup is going to take a name whose type is string, EMV whose type is environment, and then look up the environment. Remember this get function, the get method on a map, and ask, hey, environment, what's the value of name? Do you know? If there is a mapping, it's going to give you some of that value. Otherwise, it's going to give you none. Then we are going to say, oh, the value bound to this name is V, then the value of this name in the environment is V. Oh, there's no mapping for the name. It's an error, right? Oh, if the entire code is X, how do we know the value of X? If the entire code is X plus 3, how do we know the value of this one? We don't know. It's a free identifier error. Okay, it's pretty simple, but if we want to be more concise, we can write the same thing in a single line, saying that instead of using this get method, we can use this get or else method and saying, hey, what's the value of name? Give me the value. Otherwise, right? Not 42, but throw an error. Free identifier error. Now let's get to the main thing of this VAE interpreter. What's that? This new syntax, introducing a name.